Example 7. If alpha is a quadrant 2 angle with sine of alpha equal to 5 over 13 and beta is a quadrant 3 angle with tangent beta equals 2, find the sine of alpha minus beta. So keep in mind we're using one of those formulas we learned today. So the sine of alpha minus beta would mean we're doing the sine of alpha cosine beta minus cosine alpha sine beta. So in order to do this problem, we need numbers to substitute in for sine alpha, cosine beta, cosine alpha, and sine beta. Right now, all we really know of those numbers is we know the sine of alpha is 5 pi 13th. So that's the only one we have so far to plug in right there, right? So in order to find our other numbers to plug in, I personally like to draw pictures in the correct quadrants to make that happen. So let's do our quadrant 2 angle. So alpha is a quadrant 2 angle. It doesn't even matter what your angle looks like. I just like to draw it in the correct quadrant so I can remember what's positive and what's negative. Sine is 5/13, so that's opposite is 5. 13 is the hypotenuse. So we are missing the adjacent side, and it's going to be a negative value because it's second quadrant. And that's what we need in order to know the cosine of alpha. So we can do Pythagorean identity, we can do Pythagorean theorem, whatever you'd rather to find this value right here. So I'm just going to do a little, let's do square root of 169 minus 25. This is one of those nice ones, 144, I think. It's not supposed to look like there's a negative there. That just was a miswrite. So 12, is that what you guys figure? Look right? So we have a 5, 12, 13 triangle. That's not one of the ones. I should have that memorized, and I don't. Okay. So that tells us not only that the sine of, we have already that the sine of alpha is 5/13. That information was given to us. But now we also know that the cosine of alpha is negative 12/13. So we're going to be able to use that in our problem that we're doing. All right, I'm just going to move this out of the way a little bit. Okay, let's draw another picture. So this one I'm going to put in quadrant 3. I don't care what it looks like. This is angle beta. Let's see, what do we know? Oh, weird, we know tangent. So tangent is opposite over adjacent. So that would be like 2 over 1. It's probably the best way to do that, right? However, it's third quadrant, so what do we know about both of those numbers? They are both negative, and that's why tangent is positive, because a negative divided by a negative, negative 2 over negative 1 is positive 2. That works out, but that's going to be really important when we do our sine and cosine values, that we know that they're going to be negative. Okay, we got to find the hypotenuse. So we're going to have to do the square root of 2 squared plus 1 squared. So square root of 5. We'll just leave that exact square root of 5. So that means the sine of beta would be negative 2 over square root of 5, and the cosine of beta is negative 1 over square root of 5. Okay, well, here's our identity. We need sine alpha, we need cosine beta, we need cosine alpha, we need sine beta. Do we have everything we need? Yes, we do. Let's plug them in. So sine of alpha is 5/13. Notice how when I replace the sine of alpha with the ratio, the reason I keep saying this is I've had students over the years that keep writing sine next to it. No, sine of alpha is 5 over 13. The sine and the alpha are gone. It represents this, right? And then the cosine of beta is negative 1 over square root of 5. You could rationalize it if you want to. I'm not worried about it. And then cosine alpha is negative 12/13. And sine beta is negative 2 over square root of 5. So let's go ahead and simplify all that. So that gives us negative 5 over 13 square root 5. And then we have 3 negatives. Subtract, and then a negative times a negative. So that's going to be overall subtraction. So 12 times 2 is 24. And the denominator is 13 square root 5. So we have the same denominator, common denominator. We just need to combine the numerators. So negative 5 and negative 24 is negative 29 over 13 square root 5. And that is the value, the exact value of sine alpha minus beta. Now notice through that process, we never found out what alpha was. We never found out what beta was. Could we have? Yeah, we could put them in a calculator and got an approximate value for those angles. We never found out what alpha minus beta is. Do we care? It doesn't ask us to find alpha. It doesn't ask us to find beta. It just asks us to find sine of alpha minus beta. We did that. We did what we needed to do without finding the values of any of the angles. All we needed was the ratios to accomplish that.